I wonder if I'm doing this right, but anyway, I'd like to get started. Today is still, well, the last day of the New Year's holiday, I guess. It's January 4th, a day off. During the New Year's holiday, I worked on expanding the features of the Dom Hedge Fund demo that I always use for AI-related projects. Specifically, I had it fetch real market data, use machine learning to identify promising stocks, predict whether they'll go up or down, and then have the AI agent act based on those predictions. I've significantly expanded the functionality so that the AI agent actually executes real live stock trades, and I'd like to thoroughly explain that, specifically how its intricate structure is designed and how everything meticulously works together. I'm not entirely sure how long this detailed recording will ultimately end up being, but I will certainly try to go into as much comprehensive detail as humanly possible about the entire system. So I sincerely hope you'll patiently stick with me throughout this explanation. Okay, so where exactly should I begin? First and foremost, let's discuss the overall architectural structure. For those of you who are relatively new to this topic, the primary data source I'm currently utilizing is the extensive Tokyo Stock Exchange market data, which I reliably obtain from JQuants. JQuants, if my memory serves me correctly, is officially run by the prestigious Tokyo Stock Exchange Group itself, and it functions as an invaluable API service that provides comprehensive stock information. Right now, I'm actively trying out the Lite plan, which conveniently costs 1,650 Japanese yen per month. The specific types of data you can access are dependent on the particular plan you subscribe to, but even with the more basic Lite plan, you can still acquire quite a substantial amount of valuable information, like a complete list of all currently listed stocks and the four main crucial stock prices. By the way, stock market terminology can be pretty tricky and often quite complex to accurately read in Japanese, right? I genuinely hope I'm pronouncing yonhonne, which refers to the four main prices, correctly and clearly. There are a total of 4,470 stocks, including ETFs. You can get all sorts of data like this from the stock market. Things like financial summaries, scheduled earnings announcement dates, trading calendars, and so on. You can really access a lot of information. There's also data on the four topics indices, and then there's information by investment sector, like how much foreign investors are investing in each stock. Basically, you can get details about who's investing and how much for each stock, that kind of information as well. So you can actually get quite a lot of valuable features and comprehensive data, even with just the basic light plan, which is precisely why I'm starting out with this particular one. The JQuants API is truly very easy to understand and straightforward to use. The extensive API documentation is exceptionally well organized and incredibly clear. And I think there's even a dedicated library readily available for developers. Hold on just a second, please. Well, maybe I'm not actually using it in a practical sense, but it's really an exceptionally easy to use to operate. It's an API that's very easy to use. It's basically a standard, well-established REST API, so it's really quite simple and straightforward to use. I personally use this powerful tool to efficiently fetch important data, but when I do, there isn't a readily available or standard connector for directly accessing JQuants from Dome, if I remember correctly, which can be a bit of a challenge. Sorry, I have to explain a lot of important things. So the screen currently has so many different features and various tabs that it's quite hard to clearly tell where everything is located. This is specifically the code engine, and within the Jupyter environment, I primarily use Python programming language to efficiently fetch valuable data and then securely store it in a designated dataset. For example, with comprehensive master data, if you were to click on something significant like the listed company name or perhaps a rush talk, you can then easily allow it to proceed. It slowly and gracefully opened, revealing its hidden contents. Since this is indeed DOM Jupyter, we will utilize a specialized library specifically called DOM Jupyter, and then proceed to import it into our environment. In the dataset settings, there's something quite important called an output dataset, and I've meticulously set up a specific alias for it. Basically, whether it's an input dataset or an output dataset, you can very easily and conveniently configure precisely which particular dataset you genuinely want to utilize here, thereby making it incredibly simple to efficiently access and effectively retrieve the necessary data. For each individual master record, for example, the comprehensive stock information currently has 4,419 distinct entries. So every single time I completely replace and thoroughly overwrite it. For other various cases, for example, when dealing with different types of data, as for stock price information, where was it again? Like getting daily stock prices, the sheer volume of data is just too large and extensive to manage easily. So I meticulously run the process every single day and carefully append the newly acquired data to the existing dataset. That is precisely how I consistently handle this ongoing data collection. Then, subsequent to the successful collection of all the necessary data, I proceed to thoroughly process and carefully combine it. Since there are a significant number of master datasets involved, I diligently merge all four of them into one comprehensive and unified dataset, and then subsequently utilize this consolidated dataset for advanced machine learning purposes. For the machine learning aspect, I employ a dual approach, utilizing both AutoML, specifically Domo's proprietary AutoML platform, which offers automated machine learning capabilities, and also Jupyter Notebooks, where I personally install and import various essential algorithm libraries in Python to perform the intricate machine learning tasks. So in essence, I meticulously create two distinct types of predictive models, primarily regression models, I suppose, given the nature of the predictions, using carefully prepared supervised data, and then I leverage those sophisticated models to accurately predict future stock prices. After successfully generating these predictions, I then proceed to narrow down the extensive data set to a certain manageable extent, for instance, by carefully filtering the potential stock candidates based on specific criteria, before ultimately passing this refined selection to the sophisticated AI agent. If one were to pass all the raw stock data without any prior filtering, the prediction model might inadvertently include undesirable outliers, such as stocks that have experienced an unusually large and sudden rise, which could skew the results. Therefore, I always apply some rigorous filtering mechanisms before handing it over to ensure optimal performance. That is precisely how I meticulously execute this entire process. Now, here is where the situation becomes particularly interesting and engaging with the advanced AI agent. There is a well-known Japanese securities company called Tachibana Securities, and it is a notable fact that there are very few platforms or entities that genuinely provide robust stock trading APIs specifically designed for individual investors. Approximately 2 years ago, prior to my joining Domo, I was actively experimenting with this very API in Python to engage in a bit of automated stock trading, exploring its capabilities. I deployed this experimental system to Google Cloud Functions and diligently tried scheduling its executions and similar automated tasks, but regrettably, it did not go very well. It is indeed a really tough and highly competitive field, and I personally found it quite challenging and difficult to achieve consistent success. Recently, though, ever since joining Domo, I have been able to accomplish significantly more with advanced machine learning techniques like this, leveraging the powerful tools and resources available to me. I started learning and working on this a bit, and I thought if I combine this with other things, I could do some pretty interesting stuff on Domo. I wanted to use the AI agent to pull in various data and try hitting APIs like this. I'd wanted to try it for a while, but I just didn't have much time. So I gave it a shot over the New Year's break, since I enjoy this kind of thing. Honestly, there are very few places that offer APIs for individual investors. Maybe one or two other companies like AU, Kabu something securities, but their API requires you to install software on a Windows PC and go through that. So for someone like me who wants to run everything fully cloud native, it's not really a good fit. Tachibana Securities, on the other hand, offers a web API, a REST API that you can hit with POST and GET HTTP requests. This time I deployed some Python code to Domo's code engine and used the AI agent to call it, so you can do things in a cloud native way. The API is actually kind of hard to use. Well, maybe that's not the nicest way to put it, but it does have its quirks, so implementing it takes a bit of time and you need to do some testing. But there's also sample code on GitHub, and it's available. Plus, there's a demo environment. In this explanation, I'm actually using the demo environment. If you suddenly connect to the production API and start working with it, you could end up placing real orders or executing trades by accident. So, especially if you want to test things like margin trading or related features, you should first connect to the demo environment to check connectivity and debug, and then actually start using it for real. I implemented all of this on Domo's code engine. Recently, it's gotten pretty convenient. Sorry for jumping around a bit, but that's how it is. Here's a tip for development. When you're working with the API test environment, for example, when developing these days, I hardly ever write code directly anymore. It's almost become a thing of the past, hasn't it? When I develop, I usually use Python. And then for generative AI, I develop using VS Code. And I also use things like GitHub Copilot in VS Code. I have a subscription. It's about $10 a month, I think. It's actually pretty convenient. Well, it comes down to personal preference. There are all sorts of other tools out there besides VS Code, like Cursor or Windsurf, so I think you should just use whatever you like. As for me, I use GitHub Copilot. I mean, I'm more of a hobbyist when it comes to software engineering these days, so if you're doing it as your main job, it might be a bit different. But it's actually pretty useful. These models are quite handy, and even for just $10 a month, I think it's worth it. Of course, if you're developing all day, like 8, 10, or 12 hours a day, the standard $10 plan probably won't be enough for you. It definitely won't be enough. But for most people, I think it's pretty good, so give it a try. Right now, I really recommend the Gemini 3 Pro model. And on top of that, recently for generative AI, I've been using Gemini and ChatGPT, right? I'm subscribed to it, but lately I feel like ChatGPT just isn't quite hitting the mark for me. I don't know, that's just the sense I get. Compared to Gemini, I've been preferring Gemini recently. But there's actually one really good thing about subscribing to ChatGPT. It's a little over 3,000 yen a month, I think. And with that, you get access to VS Code's Codex. Am I saying that right? Codex? Codex is also included in the plan, so you can use it. And this OpenAI code generation feature, personally, compared to Gemini 3 Pro or GitHub Copilot, I definitely prefer this one. I think it's really impressive. So yeah, I use them differently depending on the situation. For really important parts, I switch over to this tab here, Codex, and use GPT-5. Codex 2, I'm not entirely sure how to accurately pronounce its name, but its incredibly powerful inference model is like super, super advanced and truly remarkable. Basically, it genuinely takes a considerable amount of time to process, but I personally think Codex is really quite amazing and exceptionally innovative. So for the foreseeable future, I absolutely plan to continue paying for my ChatGPT subscription just to specifically use this particular feature. For virtually everything else, I genuinely think Gemini is more than good enough and perfectly adequate. Also, I consistently use both GitHub Copilot and these two other fantastic tools, and I'm also currently subscribed to Gemini as well, which is very convenient. Oh, and since I just mentioned Gemini, there's a particularly useful and highly recommended feature that I'd love to share, so please allow me to briefly introduce it to you right now. APIs like Tachibana securities are pretty minor. Well, maybe minor isn't the right word. But in the US, basically no one uses them, and there are hardly any GitHub samples. So existing models like Gemini or Codex haven't really been trained on them, which means they can barely generate code for these APIs. Or rather, they tend to hallucinate a lot. So what do you do in those cases? You use the API documentation. Sample programs like this. The documentation, this one right here. You have to look at documentation like this. But what I do with this kind of information is first, I put everything related, like all these notebooks and even about 110 GitHub source code files into the LM. I just dump everything in. Once I do that, if I ask a question here, I get really accurate information. So whenever I get stuck, I ask questions here. Then I take the answers and how should I put it? I throw them into something like GitHub Copilot and say, this is the spec, so build it like this, and so on. Also, with NotebookLM and Gemini, the chop version, right? They can actually be linked together, which is super convenient. And you can create gems, right? With Gemini, you can create truly custom chats. Well, not just simple chats, but you can extensively practice here and meticulously set up highly personalized and custom interactions, like support me comprehensively with this specific kind of task, and so on, allowing for a much more tailored and effective conversational experience. Now you can actually provide the invaluable knowledge from that incredibly powerful NotebookLM tool I mentioned earlier as a primary and highly reliable resource. I'm not entirely sure precisely when this became possible, but I distinctly noticed this remarkable new capability emerging around the New Year's period. This time, for example, I meticulously put the comprehensive API documentation for DOM directly into NotebookLM. This is essentially a vast collection of crucial information that I carefully scraped from various parts of the web and then systematically dumped in there for easy access and reference. Also, there are approximately 115 detailed files from Tachibana Securities, as I previously mentioned earlier. And when I ask specific and intricate questions based on this extensive documents, I consistently get remarkably accurate and highly relevant answers because NotebookLM is being directly and intelligently referenced, drawing upon its vast internal knowledge base. So I made full and strategic use of this incredibly effective approach for the entire development process this time around. That's basically how I meticulously developed it. And those are the essential tips I genuinely wanted to share with you all. Also, when you call upon DOM's standard AI agent features, well, I'll definitely touch on this again in much greater detail later, but the overall development process kind of dynamically jumped around like this, involving various interconnected stages and iterative improvements. So for external services functioning as robust APIs, besides the powerful DOM, I extensively used JQuants and Tachibana securities, and there was one more crucial component. When I specifically wanted the AI agent to actually execute real-time stock trades, I wanted it to thoroughly fact check by diligently searching the vast expanse of the web for critical outside information. For that particular and vital function, I utilized Google's custom search API, thereby enabling the sophisticated AI agent to effectively use these powerful tools to automatically and efficiently fetch pertinent information from the outside world. By strategically using this comprehensive and integrated approach, for example, when a machine learning prediction model suggests candidate stocks, and you wonder, why is this stock going up? Maybe it's because it's being delisted due to a TOB, a takeover bid, or something like that. The system can fetch that kind of information and do a fact check. If that's the case, you might decide to hold off on buying or selling. That's the kind of thing you can do. I'll show you how it actually works later, but that's what I'm using. The great thing is you can make several hundred requests per day for free. If you don't want to worry about payments or costs, you could also use OpenAI or Google Gemini's generative AI search features via API. And honestly, that might be even better. But since this is free, I tried it out for now. Also, when you use a searchable API in the settings, you can choose how to search, like whether to search the entire web, or since this is related to stock price information, you can narrow it down to a certain extent. I wanted to focus the search on sources like Nikkei, Asahi, newspapers, Wall Street Journal, Bloomberg, and similar outlets. So I set it up like this. Also, I excluded things like user reviews as an experiment this time. So that's what's going on here. By the way, I'm also using Google's API. Honestly, NotebookLM is really great. And it's also nice that Gem can now access that knowledge. Anyway, how long has it been? Maybe about 30 minutes? Well, let's pick up the pace a bit. I'll go ahead and clip this for now since we're done with it. When you have too many tabs and windows open, it just gets confusing. First of all, when you start by fiddling with the data, after you pull the data from JQuants, what you do next is, as you can see here, you have this data flow. In Magic ETL, there's a feature generation step, and these red marked items are data sets created from Jupyter. For example, you pull stock price information, trading calendars, topics, and so on all at once like this. You basically bring all of that information together. Then, before you actually run any machine learning algorithms, you absolutely need to meticulously process the raw data to make it entirely suitable and optimally prepared for machine learning tasks. This crucial step means adding various essential features, such as calculating moving averages, for a prime example. So you ultimately end up including a wide variety of different and relevant things. You carefully tweak the data format specifically for machine learning applications, add necessary columns, and so on, and finally consolidate everything into one comprehensive and unified single dataset. That's precisely what this entire data flow process is fundamentally about. Next, immediately after thoroughly preparing and incorporating all the features, you then move on to defining and preparing the corresponding labels. Since we are indeed utilizing supervised data to meticulously train a robust regression model, this particular and crucial part of the overall data flow is precisely where we carefully and accurately attach the correct, predetermined labels to ensure optimal model performance and validity. The correct and precise labels are meticulously created as three distinct types. Firstly, 1A business B. Secondly, 2A business B. And thirdly, 3A business B. Additionally, we consider the significant effect of double sales expenses that typically occur about one full month later. These carefully constructed labels subsequently become the predicted returns. In other words, the crucial return rate, or precisely how much it demonstrably increased, is consistently utilized as the primary label this time. So in this comprehensive way, we diligently create these essential labels and then accurately attach them to the corresponding feature quantities. After that, we proceed with further analysis. In the meantime, this is precisely where machine learning truly comes in. Once that essential kind of data is readily prepared, we then let the machine learn from it. But instead of using DOM's magic ETL for machine learning, we strategically use AutoML to perform the crucial first round of training. With AutoML, you simply provide the necessary training data, and then you press retrain. Please wait a moment. I guess I should just go ahead and press it. There are about 5 million rows of data, so it takes quite a bit of time, but should I just go for it? Oh, right. The column to predict, that's the label, right? You specify something like, where is it? And then for the model, you can set it to automatic, which is fine, or you can choose whether it's a regression model or something like that, and then it'll go back. There are all sorts of powerful and sophisticated algorithms, like the highly efficient XGBoost and various other advanced machine learning types and methodologies, and the system automatically tries them all out and then intelligently suggests which particular model might be the absolute best fit for your specific needs. So after it makes a thoughtful suggestion, you can then confidently select the optimal model you have carefully created and subsequently deploy it directly to your ETL process. Once you successfully deploy it, where exactly is it located? Here in this section. There's this very useful AutoML tile, but it's important to note that it's not found within the AI services section. It's actually situated under the comprehensive data science category. Within that, there's this dedicated AutoML inference option, and after you meticulously train and successfully create a robust model, the crucial next logical step in the entire process is, of course, inference, isn't that right? So here, you carefully select the specific model, and in the dedicated AutoML section, you precisely specify which particular column you ultimately want to predict, and which powerful model to effectively use. You make your important selections, like precisely which specific column to predict, for example, and then the powerful inference engine runs, diligently telling you with great clarity, for example, exactly how many crucial business days, and so on and so forth, with all the relevant details. This is the data flow for returns after a certain number of days. And there are also data flows for returns after 5 and 12 business days. So we set up inference like that and create datasets with the inference results. That's the prediction part. Okay, let's close this. There are too many tabs open. Please wait a moment. There are just far too many, aren't there, really? Anyway, that is precisely what I am doing. But, just doing that particular thing alone isn't especially interesting. So since we conveniently have the Jupyter workspace readily available, I thought I would definitely try doing some fascinating machine learning within the Jupyter workspace as well. Yes, that's absolutely right. I am using Jupyter in this rather unconventional way. Oh, it's not this particular one. It's actually the forecast core version. This time around, instead of relying solely on AutoML, well, you certainly can perform machine learning tasks within Jupyter Notebooks as well, but I strongly believe that AutoML also utilized the powerful XGBoost algorithm, didn't it? It's a regression model algorithm. Here we are currently utilizing the highly efficient light GBM algorithm. There are, of course, several other viable options available as well, but this particular model is quite similar in its fundamental approach to XGBoost. One might even consider it a close relative in the realm of gradient boosting frameworks. If I were to have more dedicated time for this project, I would genuinely like to explore and implement even more sophisticated improvements within the machine learning component, specifically leveraging the powerful and flexible environment of Jupyter Notebooks, since one can truly fine-tune and extensively tweak a multitude of parameters and configurations there. So that comprehensively explains my current position and focus. As for the JQuants platform, within the interactive Jupyter environment, let's delve into this specific and very interesting notebook, the Stock Price Prediction Notebook, which offers valuable insights and methodologies. Maybe it's not opening. Oh, here it is. So I have successfully deployed it here and currently have it running continuously. It is actively training every single day. That is precisely what is going on. Now, when you are developing within the Jupyter environment, there are approximately two primary ways to effectively run inference. For example, you can actually deploy the sophisticated prediction model that you meticulously developed within Jupyter itself. You can deploy your prediction model to the DOM like this. It looks like this in an AI project, right here. Deploying it is one way to do it. When you deploy it like this, it shows up as a tile here. Earlier in the case of AutoML, I think earlier it was this AutoML inference in data science, but for models you build yourself in Jupyter and deploy, you use this AI model inference tile, and you select it here. 1 or 2 days, for example. So there are also ways to run inference like this. One way is to run inference on Magic ETL, and as you may have already noticed, there's also the method where you just run inference directly on Jupyter and write the results straight into the dataset, right? I have tried both approaches, but this time, since I needed to use a lot of data and do more detailed work, I found it easier to handle everything on Jupyter. So I've set it up to have both the machine learning training function and the inference phase function on Jupyter. For training, it's more of a manual process. When I want to, I retrain and create a new model. As for prediction, that's inference. The inference part runs every day, like in the morning when new data comes in, such as updated stock prices. It doesn't retrain the model, but instead runs inference and writes the results into the dataset. That's pretty much all there is to it. So let's gradually and gently wrap this up now. Did I have it? Maybe I didn't display it. Before this evaluation, Mart, I've put it all together. I've organized this for learning purposes. Basically, that's what it is. Integration. Oh, here it is. So each of these machine learned models, well, the machine learning inference results 5 times a day. Each data set is different, but in the end, I combine all of them into one. Basically, it's about integrating these prediction results. It says horizon here. Yes, so I put them in here. That's what this is. Yes. So I put all of this together, and then finally, did I close it again? Sorry about this, really. It's just a demo environment, ours. Yes. So what we're doing is creating a mart. Ah, here it is. Right. And so in the end, in this evaluation mart, well, it's a data set, right? It's for this person to view, this one. It's for use in the dashboard. So the data, we're creating it. And with the ETL from earlier, well, for example, for 4,000 people, what was it? Well, since it's investment, people like Densan or our own staff, they're large scale users, our clients, like Rakuten, for example, or say KDDI. Oh, this is in full with characters, right? So KDDI, I think for sure. And then like Toyota Motor Corporation, are they included? Well, just as an example. When you search, well, the predictions from Jupyter and AutoML, you can now compare how things are going for each individual stock. Like this. You can narrow down the period, especially if you do it this way. This is a prediction for 20 days later. Well, the new year hasn't started yet, the market. So you have the actual data up to December 30th, and then you can see what happens after that. AutoML is making these predictions, for example. Basically, this is how the future part looks. This is the part about the channel, right? That's how it's set up. Now, from here, we're going to start talking about AI agents. So up to this point, we've been discussing predictions. Next, we're moving on to the actual buying and selling of stocks, which is really the main thing I want to talk about today. And I think it's the most interesting part. So I'd like to get into that. So first of all, actually, this is the API part, right? Since we needed to create the section for Tachibana securities, we went ahead and built this Tachibana broker. So, so what is this doing? This function is, well, pretty impressive, but at 4,000 lines, it's not actually that long. It's 4,005 lines, didn't quite hit 5,000. I don't think there were that many steps, but basically, these are the functions for Tachibana securities, right? Like your own portfolio holdings, right? Physical stocks. And where was it? Yeah, well, you want to call up a list of the portfolios you hold, things like your current account balance, your holdings, and then positions. These are called open positions, basically margin trading, right? So your own portfolio, and also like what kind of orders you've placed, or, that kind of thing. Placing orders, and then the order history, like whether your limit order was filled or not, that kind of thing. Also, the various types of information that, well, are often provided by services like JPorts. It turns out you can actually get a lot of that info through Tachibana Securities API as well. I found that out recently over the New Year holiday when I tried messing around with it. Yeah, you can even get news information too. Once I realized you could get that, I started pulling it in. And since you can use it for free as long as you have an account, I think Tachibana Securities API is actually pretty interesting. Or rather, it's really convenient. Yeah, I think a lot of the stuff provided by JCons is probably free and covers a pretty wide range. This one might actually let you access even more information. So for things like that, I've put together a set of features like this, which are probably necessary for an AI trading agent to do automated stock trading. So for example, let's try asking something like this. It would be a bit of a waste to use Gemini for this, so let's use the free 4.1 version or something like that. For example, about the library, about the public functions. Well, each feature, if you try asking something like, tell me about each feature, well, it doesn't work in agent mode. Let's try it in question mode. The source code is actually pretty long. Well, it's not really a problem though. For example, in the beginning, you log into Tachibana securities like this, get a virtual URL, and then reuse that throughout the session. It's a session that's valid for a whole day. And how should I put it? For each session, you need to increment it or something like that. Yeah, sessions like this. And so it begins. The so-called dead decision context can actually fetch detailed information like stock prices and even the order book data for the stocks you're interested in. All of it. You can also accurately see within a certain range how many buy and sell orders there are. And then this is also the kind of data you can get with JCons, stock price information like this. Is this the 4-point chart? 4 points, right? Well, anyway, you can get it. This one here, you can actually get 20 years worth for free, but if you pull all 20 years, it gets way too heavy. So for now, let's just get the most recent 5 days. That's what we'll do this time. You can also get things like PR or PPR, as well as company information and news. And you can pull all of that together, including things like margin balances. It says here it's for developing AI model-based trading crime strategies or something like that, but that's actually true. And then for trade state, it's about the stocks you own and what kind of information, well, you know. You can also get information about your portfolio. And then there's the market status, right? Like whether the market is open or closed. You can get those kinds of statuses to the Tachibana AP Securities API. And also, um, order details, yes. Basically, trading profits. You can get your trade execution history, order status, and things like that. And then this is where you actually place orders. Spot trading, margin trading, new orders, or rather margin trading. So basically, you can do all kinds of margin trading as well. I implemented it so that it can handle everything, including that, for every possible case with these kinds of functions. Lastly, the search web function is basically like Google, as I mentioned earlier. The AI agent can call this function, and it allows it to fetch information from the outside world, from the internet. Well, if it were just news, you could get it by using the API from Tachibana Securities with the stock code. But it's not just that. For example, you might want to know what kind of announcement the Bank of Japan made internationally, or if there's some conflict happening somewhere. You want to be able to get that kind of information too, right? I think that's really important. So before making any trades or anything like that, it's set up so that the AI can properly assess those things as well. Something like that. There are 7 public functions. That's it. So, I'm gonna delete this one too. Delete. So, yes. So here it is. You know, it's gonna be an AI agent, right? Oh, sorry, the one I just developed. So what you do is deploy what you develop to this kind of code engine. Once you've deployed it to this kind of code engine, well, the public functions are down here, by the way. So after you deploy it, well, that's fine. I'll just close this too. There's an AI agent in this kind of workflow, right? There's an AI agent, and in the settings for this AI agent, oh, let me save my changes. I'll reopen it now. Okay, so there's a prompt. There's a prompt. And then in the tools section here, this is where you can call the functions I explained earlier, like the deployed ones, the web search, or Google search, and so on. And then in addition, things like config information or authentication details that are set up on Domo are configured here as well. Finally, at the very top, there's the audit feature provided as a standard by Domo. The create, update, delete document is, as I showed you earlier, the execution log. The AI agent leaves an execution log every time it runs, and this is stored as a dataset. The execution log itself is this. It's the appdb, right? It's saved in the appdb in JSON format. So do you put that into the dataset? Well, you can sync the opdb to the dataset, and it's set to sync every 15 minutes. Basically, it's syncing. Yes, so that's how we keep it in sync. And this dataset, this is in the dataset knowledge section, where we have the execution logs. Each time it runs, the AI agent checks its past execution logs, so it can see how things went before. Also, there's the automated trading signal dataset, which I mentioned a bit earlier. And this here is the execution log. This is the data source right here. Now, you can also view it in the operation status tab, where the displayed candidates are shown. Yes, that's how it works. So, yes, the incident log. This is the execution log. And then, oh, right, this trading signal is. The data set after the exit, well, that's right. It contains all the past data for previous states. So in the data set from the last inference run on the current day, we apply quite a bit of filtering and such. Also, there's the AutoML version for all 4,400 stocks, and with the Jupyter version, it gets to around 8,000 or even close to 10,000 rows. So instead of passing all of that as is, we try to filter out what might be considered noise. For example, companies with a small market capitalization. You know, stocks like that tend to have really volatile price movements. I guess you could say the order book is then. Those kinds of stocks are, well, for institutional investors, how should I put it? Even just with retail investors, those stocks are pretty easy to get played with, right? Or rather, they're kind of risky. So, how should I put it? It's better to exclude those kinds of stocks. I exclude those to some extent. And after filtering them out, well, I'm not sure how many there are right now, but I narrow it down to about 70 or maybe 100 stocks as potential candidates. And then, well, I pass those to the data set as these automated trading signals, kind of like what I'm feeding into this data set. How many rows is that? It's about 76 rows, I think. So, holdings, that's the prediction data. I pass this to the AI agent and use it as a reference when selecting candidates. That's how it works here. Yes, for short candidates, short and long positions, whether it's spot trading or margin trading, I've set it up so it can handle both. So for predictions that say the price will go down, huh, and for the ones expected to go up, long positions, for those that are predicted to rise. Basically, I include both types of data. That's how it is. Yes. So this is the data set, and there are two things we pass to the AI agent, this data set and the execution log, using a tool like this. Then in the end, we save everything to UpDB. That's basically what's happening here. Also, here's another part. Tachibana Securities APS session management. Basically, when you're running things, the Tachibana Securities API uses something called a sequence number, right? You send an HTTP request once, and then the next time you have to increment that number. You have to keep doing that, but you need a place to store and remember it. So we save that in this data set, and the AI agent refers to it, adds the sequence number, and then makes the request to the Tachibana Securities API. That's how it works. So about the prompt, this time we're still connected to the demo environment of Tachibana Securities. We've implemented a full range of features in the reporting engine, including margin trading and various other functions, and we're running it all with a single user, partly for debugging purposes. We've been working on this for a while, so the prompt has become pretty aggressive. It's something like, you are an autonomous hedge fund manager who skillfully uses the Tachibana Securities API, machine learning, and web search. That's a verb. Like trying out simultaneous orders for spot, margin, short selling, market, and limit orders, and pushing the system's feature coverage to the absolute limit. Stuff like that. So basically, that's the Constitution, right? I'm writing the Constitution, the system stress test Constitution. Basically, it's written in a way that uses each function. Oh, and one more thing. This is about the AI agent at the end, but here's a tip for keeping it running stably. When the number of these kinds of tools increases a lot, if you don't put some thought into it, it often won't behave the way you expect, like with the arguments passed when calling functions. It's pretty common to make mistakes with the settings and things like that, especially as the number increases. But even if you have a lot of these, there are tips to keep things stable. Um, when you call each individual function specifically, for example, after logging in, the return value of the next function will include information like, hey, maybe you should call this function next, such as get market status or get decision context, along with how to use them, like, here's how you can use this. That kind of information comes together. Um, so after calling something like AI person, that information is included in the response. The explanation is really detailed. Well, this isn't the MCP server, but the MCP server probably works in a similar way, right? Since it's a protocol where AI teachers and AIs interact with each other, it's kind of similar. The underlying mechanisms might be a bit different, but I think that's the general idea. It has that kind of vibe. Well, something like that. Or rather, it's being made to do that. So, for example, with that API, well, when the function tool call fails, there's something called next action. When it succeeds, you can use it like this, and even when it fails. For example, when sending mail, net market, when sending mail. That order, the actual trade. When it fails, along with this kind of error, you can use this in meetings like this, or it's an actual sample, right? There are also samples like, please provide these parameters included as well. So it's just a single call. Even if it fails, you get a sense of, oh, this is how you call it. And the AI agent will go and try calling it again. It's pretty interesting, isn't it? So I've included a lot of explanations like that. I went into quite a bit of detail. So with things like this, when the AI agent is calling the functions of the reporting engine, it can come in and figure out what to do next. Or if it fails, it can understand, oh, this is how you use it. Because of that, even if there are quite a lot of tools, it still runs stably. It really does run very stably. I think this is a really important tip. So that's what I wanted to share. All right, so I've explained the tools, I've explained the knowledge. So now let's actually, well, since it's currently running on a schedule, it wouldn't be good if it started up twice at the same time. But since this is a test environment, it's fine until 3 a.m. You can use it, in the demo environment. Once the securities part is over, the market closes and the status will be like not open or something. So let's go ahead and run it. This is pretty interesting. Well, right now I'm running a bug check every 5 minutes, so it's already running. The AI agent is probably already active. It's currently running, so I feel like running it twice at the same time isn't a great idea. But, well, what should I do? Maybe I'll try scheduling it once. Let's go ahead and delete it for now. Delete it and then run it. This is just a single run though. It takes about 5 minutes, quite a while. Sometimes it can take 6 minutes. All right, whatever. Let's just try running it as a test. I'd really like to show you how it works. So this AI agent, when you want to test automated stock trading, you set it up on the screen and then test the agent. Okay, so now it's about to start running. Yeah, so it ran just like this. But when I say aggressive, I mean autonomous operation. First, it checks the market conditions and available margin signals, and then it does a web search for things you might want to see, so keep an eye on that. Then, regarding the data set, it asks for the top 10 stocks with the highest predicted returns and the stocks with the most extreme long short scores. In this example, it's already pulled that information. It takes about 5 or 6 minutes. Yeah, it calls APIs and such. Oh, and this is the data set, right? The score from the earlier prediction. With the data set, the market is like this. I guess this is the afternoon session. It's currently accepting orders, and the available margin is this much. If you had this much, you'd be happy, right? 139 million of that. Like this. And what we have now are signals. Yeah, like there are top candidates without maintenance rates. And for the top stocks we hold, we get similar information from the news, check materials through web searches, and so on. Basically, if you equip the AI agent with tools, Well, it depends on the prompt, but the good thing is, unlike a regular workflow where things just flow in a pretty rule-based way, like do this, then this, then this, with AI agents, the tools can handle things even when there are branches or loops. I think there are about 7, like I mentioned earlier. And if you let it use those freely, it can read this over here once, then go over there next, and if that's not it, go back again. Basically, it can use the tools in a cross-functional way like that. It can actually do that. I think this is really great. And now, is it web search? This one? Oh no, that's not it. This is this is uh this is the Tachibana Securities API. Right now, I'm pulling stock information, but this actually takes quite a bit of time. Since it's going through the stock codes like this, I think the response time is pretty slow. So it takes about 5 or 6 minutes. It's a pretty heavy process. It takes that long. So for this automated trading AI agent, it fetches data based on the predicted results, checks its own positions, and goes through the whole process. So each run takes about 5 or 6 minutes. But I've also implemented it with Code Engine, so it can be used for other purposes as well. For example, you could use it to create a data set of undervalued stocks in advance, like by looking at their PE ratios or something, or by narrowing it down by looking at things like PBR, and then you could make something like a watch list out of that and have it do the buying and selling. There are all sorts of strategies you could use. And already, the tool is already built. From here, the strategy part is totally up to you. It's all free and open, so I think it would be interesting to create all kinds of AI agents for stock trading. Yeah. And since it's implemented in Python, well, I'm not actually a Domo employee or anything, but Domo is a corporation. Well, Domo is really aimed at enterprise users, so there isn't really a personal use case for it. I don't think most companies would let individuals do this kind of thing in their work environment, so that's that. But if you can see how AI agents can be used like this, you'll realize there are all sorts of ways to apply them elsewhere. Personally, through this experience, I've really come to see the potential of Domo's AI agents. It's amazing just how much they can do. Now that I understand that, I want to keep applying this kind of thing more and more. And well, I want to learn and share that knowledge with others. That's what I'm thinking. Also, since the code engine is built in Python, well, it's written in Python, so you could deploy it to Google Cloud Functions, or I think it's called Google Cloud Run now since the name changed recently. You could deploy it there and use it with other AI agents as well. Well, since I've already modularized it, I think it's pretty easy to work with. So if you're interested in any of these functions, I can definitely share them with you. No problem. Yeah, well, it's nothing special, but feel free to reach out if you want to discuss it. I actually look through Tachibana Security's API GitHub quite a bit, but honestly, yeah, it's kind of like they don't really have it organized as a library. It's more like, for this case, check out this Python file. It's a bit hard to understand, so I went ahead and organized everything properly. So, well, it's not like it's on GitHub or anything. I mean, I could make the repository public, but yeah. Oh, and look, it's running while I'm talking about the repository. What do you think? It's pretty interesting, right? Watching it move like this? So, like this. And one of the orders failed. So it actually went all the way to placing real orders. Amazing. It really is amazing, isn't it? And then, oh, and it looks like you can also check whether a stock is eligible for margin trading. As for whether a stock can be shorted, it seems you can check the status with the Tachibana Securities API, but I haven't added that logic yet. So sometimes when it comes to short selling, yeah, sometimes it says something like an error occurred, but I'll fix that up and polish it a bit more when I have time. Then it's a matter of whether to connect it to the production environment or not. I do kind of want to try it out, so maybe I'll give it a shot, just a little bit. Well, that's about it. The rest is about strategy. This time, since it's a prompt demo environment, I'm doing things pretty aggressively, including bug fixing and all that. It's more interesting if you use a bunch of different features, right? But still, yeah. Um, If you're actually going to run this for real, I feel like it's better to start without margin trading and just stick to long positions, only spot trading. Yeah, well, it's pretty cool that with APIs, even individuals can actually trade stocks like this. And on top of that, having an AI agent think things through like this, well, that's one thing wrapped up. Just like this, I am also making sure the logs are properly kept up to date. Also, you can get news information, and since it does web searches too, it's kind of like fact checking. Everything, like the reasoning behind why it made certain decisions, is all saved in the logs. Yeah, exactly. And these are the order results, right? Like limit orders and so on. It actually checks things like the order book depth and stuff like that. This is the info here. It's a bit long since it's in JSON though. This is pretty amazing. Hmm, this is a bit too long though. Ah, so the data and the API have changed. Yeah, like this kind of thing. These are the list of orders. This one, this, and also web searches. You're doing web searches here, right? From the web search results. Seeing a market downturn as a short selling opportunity. That kind of thing. This, web search, Google search. It's already coming in. And based on that kind of information, it helps you select stocks and PR targets, and not only checks the news, but also does fact checking through web searches. Honestly, I was amazed, or rather, it was just really fun over the New Year's break. I really love this kind of thing. That's pretty much how it went. Yeah. With these kinds of tools, the AI agent uses tools to access knowledge, keeps logs, and so on. It really feels agentic all the way through. Yes, so I have successfully created something truly remarkable that performs automated trading, operating completely autonomously and with impressive efficiency. This particular demonstration is merely a small sample of its capabilities, but if you were to reach out to me directly, I would be more than happy to share a more comprehensive and detailed version of the sophisticated system with you. So please feel free to consult with me at your earliest convenience regarding your specific needs and how this technology could benefit you. However, among our valued customers, among the many satisfied users, well, I don't think there are many companies that would actually let you do stock trading like this. Most of our clients use it for corporate purposes, so things like this are pretty rare. But I do think it's interesting as a reference. If you're interested, I can provide these kinds of tool sets. And then let's see. Let me just show you a bit about UpDB. UpDB, UpDB. Yeah. Um, Right. So including the meaning of bug tracking, this is basically a log list. It's already been run about 140 times, and the very bottom one is the latest. This is the data set that's linked with what I mentioned earlier. So when you look at something like this, yes, you can see what kind of execution results you got. Also, the AI agent can check the logs before the next run and see, oh, this is what I did last time. So based on that, it can make decisions as well. I thought this kind of approach is actually pretty useful. That's what I wanted to say. Yes. So, my recent New Year's holiday was truly very enjoyable and quite relaxing. That's essentially about it. I genuinely realized that advanced AI agents can actually perform these kinds of complex and interesting tasks. That's all for me for now. All right, if you have anything you'd personally like to ask, please feel free to ask me various questions. Well, I wouldn't say we've reached the absolute limit, but this is pretty much the limit of what these AI agents can do. Yeah. So I learned a lot by trying out things like, wow, it can do that much? Well, that's all I wanted to share. That's it for me.